And we are live. So you guys test tomorrow. Woohoo! So we'll do the review today. I'm in the building, but I'm going to be working on math stuff. So 11, 6, 19. Okay, so I think the big key to the review is this. Remember your mode, because some questions are going to take Radian mode, some questions are going to take degree mode. We just have to remember to switch it back and forth so we don't do the right problem and get the wrong answer, okay? All right, number one, this is Radian mode. Okay, so I'm going to do that first, right at the bat. Take my calculator, I'm going to turn it on. I'm going to go to my mode button. I'm going to make sure it's in radians, and it is. Okay, so switch it over to Radian mode. All right, number one, easy. You can't miss this one. Just go cosine 3.3, all right? And you get an answer of about negative point, let's round to the nearest thousandths, negative 0.987. Negative 0.987. Boom. Can't miss that one. Number two, cotangent. Well, there is not a cotangent button on the calculator, but there is a tangent. So we're going to rewrite this as 1 over tangent of 4.2. Sorry, so sloppy. I'll put it up here. 1 over tangent 4.2. And I'm just going to use my calculator. 1 divided by tangent 4.2. And I get an answer of about 0.562. 0.562. Okay, go ahead and pause the video at any time it gets going too fast. And then you guys can catch up. All right, secant. Again, there's no secant, but there's a cosine button. So we're going to go 1 over cosine of negative 1.2. I'm just going to use my 1 divided by cosine negative 1.2. These are easy, and I get an answer about 2.75260. 2.760. 2.760. Finally, sine of 3/4, so sine 3 divided by 4, and I get an answer of 0.682. 0.682. Okay, now, those you better be able to get. So, 5, 6, and 7. If I need a reference angle, what I'm going to do is this. I'm going to go ahead and draw a picture. So I'm going to go and switch over and do 5 on a blank piece of paper because I've got to draw. I want to draw it. It helps me if I draw it. Okay, number 5, 7 pi 6. If I look at the unit circle, 7 pi 6 is right there. Okay, if I need a reference angle, you need to make the right triangle that's flush to the x-axis, all right? So if 7 pi 6 is all the way around here, then this angle here is my reference angle. That's got to be pi 6, okay? Number 6, negative 2 pi thirds. Let's see. Positive 2 pi thirds is here, so negative 2 pi thirds is here. Okay, you can look at the unit circle, but positive 2 pi thirds here. If I rotate backwards, negative 2 pi thirds is here. If I make my right triangle flush with the x-axis, here's my theta. My reference angle is going to be pi thirds. Okay? And I will be here tomorrow morning if you guys have any questions. Come see me. I'll be here flex also. 7. Okay, 5.5. Now do 5.5. Let's see if we can figure out some things. I know 0, pi halves, pi. I know this is 3 pi halves, and this is 2 pi. All right. This is not hard if we think about these in terms of decimals, right? So this is, as a decimal, 3.14, blah, 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 okay? 5.5 is on there, but let's figure out where. So 3 pi half, so I just take 3 times pi divided by 2. I get about a 4.7. About a 4.7, so we'll put a 4.7 here, okay? And then finally, 2 pi is got to be about a 6.28. So 5.5 is somewhere in here. 5.5 is going to be somewhere in here. I know 5.5 is more than 3.4, more than 4.7, but not quite 6.2. So my angle is here, okay? So if I think about it, if I rotate all the way around to 4.2, 5.5. If I keep going, I'd have 6.2. So to get the reference angle, let's take 2 pi and subtract out my 5.5, and I'll get my reference angle. 2 pi minus 5.5, and I get an answer of about 0.73, so my theta is about 0.783 radians. Okay? So what I did is I knew that all of these pi units have a decimal equivalent. So I figured out what their decimal equivalent was, found out the 5.5 is about there. The angle between here is in between 2 pi, which is 6.28, and the 5.5. All right, number 8. All right, same kind of thing with number 8. Let's take a look at number 8. I've got -2. All right, so let's go backwards. So if I made this, if I go backwards, if I go 0, if I make this a negative pi half, so going backwards, right? So negative pi halves, we found out was negative pi halves is about a negative 1.57. So the 2's got to be around in here. -2, it's got to be a rotation to right about there somewhere. So the angle I'm looking at is here. Okay. Okay, this is 180 degrees, but we're not doing degrees, but I'm giving a reference. This is pi. So the angle I want all the way across be pi, minus this angle puts me the reference angle. So let's go pi, and we'll subtract 2, and we'll get the reference angle. So if I go pi, and I subtract the 2, I'll get an answer about 1.14 as my reference angle. 1.14. Okay, little tricky, but come see me tomorrow if you're a little confused on this, or I can go over it again one more time before we take the test tomorrow. Okay, all right, easy stuff. Find the missing angles and sides of this triangle. Okay, so right triangle trig. I'm going to put this on a separate sheet of paper too. Here's the easy stuff. Everybody better be able to get this right. I'm kind of embarrassed this is even in this book because we're in pre-calc. Okay, so what do we know? We know that's 8. What can we find? Well, let's pick an angle. How about angle A? So if I pick angle A, that's my opposite side. That's my adjacent. If I need the angle, I'm going to go tangent of A is equal to my opposite over my adjacent. Okay, and then all I'm going to do is take the inverse of that. Tangent inverse, because I'm looking for the angle, of 8 over 5 foot. Wait, stop. Degree mode. Because I was just in radian mode, right? So I'm going to go back to my calculator. Wait a minute, don't make a dumb mistake, Bill. Let's go back to mode, degree mode, enter, quit that. So I'm going to go tangent inverse of 8 divided by 5. And you can pause the video if you need to go ahead and change your mode. But I changed it back to degree mode. Tangent of 8/5, enter is about a 58 degree angle. So angle A is about 58 degrees. Okay, angle B. Well, angle B is easy because I know that angle B is just going to be 90 degrees minus my 58 degrees because my two acute angles are always going to be complementary, meaning they add up to 90. So 90 minus 58, and I get an answer of about 32 degrees. Okay. So I've got 58, I've got 32 degrees, and then finally, if I want to find this side, little c, I'm just going to use Pythagorean theorem. It's probably easier. So let's go 5 squared plus 8 squared equals c squared, right? A squared plus b squared equals c squared. 25 plus 64 equals c squared. Let's see, what is that, an 89? 89 equals c squared. Square root of 89, that's what calculators are for, and I get an answer about 9.4. We can always go to the nearest tenth on right triangles. 9.4 is good enough for me, and that's in terms of centimeters. Okay, again, I'll be around tomorrow morning. I'll be here at Flex tomorrow, so if you're stuck, come see me. You should be able to do that. Okay, number 12. Let's look at the unit circle. Hopefully everybody's staring at the unit circle. 12, we need sine of pi 12s, okay? Sine of pi halves. Pi halves, I'm looking at it, it's 90 degrees. Sine is the y value. It equals 1. Boom. When it says exact value, that's what I want. I don't want to calculate our answer, okay? 13. Cosine 5 pi thirds is at 300 degrees. You guys see it? 5 pi thirds, 300 degrees. Cosine is the x value, positive 1/2. Boom. Okay. Tangent 7 pi 6. Well, let's see, that's at 210 degrees. Tangent values, those are the green ones on the outside of the unit circle. It's the y over the x, so it's the square root of 3 over 2. I'm sorry, square root of 3 over 3. I said it wrong, but I wrote it right. Square root of 3 over 3. Okay. Cosine negative pi thirds. Well, negative pi thirds is really at 300. So we're going to rotate down. We're going to rotate backwards. So we go to 300 degrees. We want cosine, which is the x value, which is a positive 1/2. Okay, again, if you get stuck, have video paused. Go ahead and get caught up, or come see me tomorrow, okay? Secant. So what I want is 1 over the x value, okay? Because that's secant. So I go to 5 pi thirds, and 5 pi thirds is at 300 degrees. The x value is 1/2, so it's 1 over 1/2. If we flip it up, it flips up to 2. Okay? Cosecant of 3 pi fourths. Well, cosecant is 1 over the y value. 3 pi fourths, let's see, that's at 135 degrees, okay? And I want cosecant, which is 1 over the y, and the y value is square root of 2 over 2. And that will flip up and rationalize to plain old square root of 2. And you can go ahead and work on the rationalization. I could do that for you later, but that's the way it is, okay? Get 2, well, okay, I'll do it for you. 2 over the square root of 2. Fix the problem with the problem, right, Zoe? Fix the problem with the problem. And then I get 2 square root of 2 over the square root of 4, which is 2, and the 2's cancel. Boom, there it is. Slick, huh? Cotangent. So cotangent is the x over the y. If I go to 2 pi, which is 306 degrees, I've got the x over the y. So it's a 1 over 0, but you cannot divide by 0. 0 on the bottom is bad, makes Cookie Monster unhappy, so it's undefined. Okay, cosecant negative pi over 2, which is going to be 1 over the y value. So this is at 270 degrees, because we rotate back pi halves, it's at 270 degrees. Cosecant's 1 over the y value. The y value is negative 1, so we got 1 over negative 1, which is negative 1. Boom! Like it. All right. 20. I'm going to need some paper here, okay? 20. We're going to need some paper and a calculator. So, car wheel, diameter 14 inches, which means the radius is going to be 7, right? Spins 14 revolutions per second. Okay, so here's what we're going to do. It's kind of like a circumference problem, okay? So we know that it's going to be rate is equal to distance over time, right? So what we're going to do is this. We're going to go ahead, and the distance is like its circumference, right? So it's going to go 14, so theta, it's going to go around the circle 14 times. Or 14 times 2 pi, because once around the circle is 2 pi, but you can do that 14 times, all right? Now, the next thing we do is take that and multiply it by our diameter, or by our radius. Diameter, because circumference is diameter times 2 pi, no radius. So multiply that by 7, and so then theta is going to equal 14 times 2 times 7. I got 196 pi, and that's, in a sense, how far it's going to go in 1 second. So let's do our conversions, okay? So this is 196 pi inches in 1 second. Okay, got to go miles per hour, okay? So let's do some conversions. There are 12 inches in 1 foot. There are 5,280 feet in 1 mile. Okay, now I got miles per second, but I got to do miles per hour. So then I'm going to multiply it by 60 seconds in 1 minute. And then I got to get to miles per hour, so there are 60 minutes in 1 hour. Okay, let's see what we can cancel. See if we cancel some words and see what we get left. Okay, let's see. First of all, inches cancel with inches. I like that. Feet cancels with feet. Let's see. I've got seconds cancels with seconds. I've got minutes cancels with minutes. What are my words left? Miles per hour. Select. Okay, so let's multiply all that. So I'm going to take my 196 pi times 60 divided by parentheses 12 times 5,280, and I get a grand answer of about 35 miles per hour. 34.9, about 35 miles per hour. Cool. All right. Let's move on. 21. I'm going to flip it over. And again, if you guys need it paused or rewound, you can. So I got a discus ring, right? And the diameter is 4 1/4, which means the radius is 2 1/8, right? So the radius is 2 1/8. That's my radius. It has a throwing angle of 35 degrees. And then they got this thing called a foul line or a toe board. That's right there, okay? And I need to know that arc length. So my formula is S equals R theta. That's the formula. S is the arc length. Radius times theta. But theta is in terms of radians. So I do my conversion. I'm going to go 35 over 180 times pi. And that's going to convert it to radians, all right? And I'm just going to use a decimal because I don't care. I need a decimal for that length anyway, okay? So that's my angle. Now my radius then is 2 1/8. So my arc length is 2 1/8 times 35 180th pi. All right, so let me do that. Let me do that on my calculator, okay? So I'm going to have a 2 1/8. Well, that's the same thing as 17/8. So I'm going to go 17 divided by 8 times 35 pi divided by 180, and I get a grand answer of about 1.3, which makes sense because this is in terms of yards. Is it yards or feet? Yeah. Feet. 1.3 feet for my throwing board, okay? Now, if I want the area of that sector, the area, symbol's K, I don't know why, 1/2 R squared theta. But theta is in terms of radians. Theta's got to be in terms of radians, but luckily, I already know what that is. Theta is already going to be 35 over 180 pi, right? Okay, so let's plug that in along with our radius, which is 2 1/8. So my area of my sector is 1/2 2 1/8 squared times my 35 pi 180th. And I'm just going to use my calculator to do that. Let's see, what do I got? All right, I'm going to go 0.5. I'm going to parentheses and I'll make that a 17/8 squared times 35 pi divided by 180, and I get an answer of about 1.38 feet squared. It's not a very big area, is it? It's all right. Okay, moving on. Number 22. Oh, I didn't even need to do that one, did I? No, I just got interrupted, so that happens when I get interrupted. Okay, 22. An automatic sprinkler sprays a distance of 24 feet while rotating 40 degrees. Okay, all right, that's what I meant to do up here. Okay, so it goes like this. Okay, it's going, and this is my 24 feet, my 40 degrees. So, okay, let's do this problem again, but with different numbers. K area is equal to 1/2 r squared theta. But theta's got to be in terms of radians. So let's convert it. I'm going to convert it over here. So my theta is going to be 40 over 180 pi. That's my conversion from degrees to radians, okay? So my radius is 24, so my area is going to be 1/2 times 24 squared times theta in terms of radians, which is going to be my 40 pi over 180. And I'm just going to use my calculator. This time I'm going to do it right. You guys got an extra problem. 0.5 times 24 squared times 40 pi divided by 180. And I get an answer of 201. Yeah, about 201.1, 201.1, and that'd be in terms of probably feet, right? Feet squared of area. Okay, you can do this. You can. Okay, we're getting there. Turn the page, okay? 23. All right, let's take a look at 23. All right, now comes the easy stuff. A 6-foot man sights the top of a building at an angle of elevation of 74 degrees. If the man is standing 120 feet away, how tall is the building? Okay, let's draw a picture. Here's my 6-foot man, which means I will add in the 6 feet when I'm done. Here's my building. No, it's not drawn to scale at all. Not at all. 74 degrees. He is 120 feet away. Now, here's what we're going to do. We're going to find this right triangle. And then what we'll do is we'll add in 6. Okay? So we'll find x, we'll find the height of that building, and then we'll add in the 6. We'll go plus 6. Okay, so that's not too bad. Opposite, adjacent, tangent. 74 equals x over 120. And multiply up the 120. 120 tangent 74 equals x. All right, let's make sure my calculator's in what kind of mode? What mode? You're right, degree mode. Of course, I think I'm still in degree mode from the last problem I did. Yep, of course I am. So let's just go straight to my 120, and I'm going to go tangent of 74, and I get an answer about 418.5. But then I'm going to add in the 6-foot man. Have to add that in, and I get 424.5 feet tall. Okay. 24. Cruising along. Hopefully I'm doing a good job. You can always pause it anytime you want to or rewind it, and I will put it on the web page tonight. Okay. All right. 24. A wheelchair ramp is constructed, height of 8 inches, and a ramp length of 52. What's the angle of elevation? So it's kind of important with code because certain codes have certain ramps be certain size because grandma's got to get up the ramp, right? And if it's too steep, then it won't make code. So if this is 52 and this is 8, let's find the angle. All right, well, I can do that. Opposite, right? Hypotenuse. Let's use sine of theta equals opposite over hypotenuse, 8 over 52. I need to find the angle, so I'm going to use my inverse button. So I'm going to go sine inverse of 8 over 52. So let's see, sine inverse 8 divided by 52, and I get an answer about 8.85 degrees, which I think is within code, 8.85 degrees. Grandma JoJo can get up that one, maybe. Okay, last problem, last but not least. Okay, you ready? Let's do problem number 25. And then I've got a little homework assignment for you, okay? Okay, find the area of this isosceles triangle. So let me draw it out. 50 degrees, 16, 16. Okay, so I know the area of a triangle is 1/2 base times height, right? But I don't know the base. So let's make 2 equal right triangles. We'll find the base, and then we'll find the height, and we'll find the area. Okay, so first of all, if this is 50, I just cut it in half. So I got 25, 25. So I'm going to go ahead and redraw that triangle. So this is 25. This is 16. And if that's 25, let's see what's 90 minus 25. 65, right? Hey, come on in. I'm recording. Don't worry about it. I'm going to be gone tomorrow, so I'm just recording the lesson. Come on in and just ignore me. Okay, 65. So here's what I want to do. I want to find the base. Let's just call this B for base. And I want to find the height. All right, I can do that. So let's find the, let's find the base first. Let's see, that's going to be my adjacent side, and that's going to be my hypotenuse. So let's set it up. Cosine 65 is equal to B over 16, right? Adjacent over hypotenuse, I'll multiply up to 16, right? And I'll go 16 times the cosine of 65 equals B, right? 16 times cosine 65, and I get an answer of about 6.76. But I'm going to double that, right? Times 2. You're right, Evan. We don't need to double it. 13.52. Okay, now let's find the height. Okay, two ways. We could either use Pythagoras theorem, or I could use sine. I'm just going to use sine. Sine of 65 is equal to my h over my 16. Opposite hypotenuse. Okay, multiply up to 16. 16 times the sine of 65 equals h. Again, if I'm going too fast, pause the video and catch yourself up, okay? 16 times the sine of 65 is about 14.5. Okay, I got it now, okay? So, area of my triangle is 1/2 13.52. I know, Evan, we didn't need to take half of this because that's half of that anyway. Times 14.5. So 0.5 times 13.52 times 14.5, and I get a grand answer of about 98. 02, but about 98. I don't know if it's centimeters or what. I forgot to label it. Let's just call it centimeters squared. Okay. You have homework. You really do. I really want you to work on this. I will stamp it tomorrow. You can do this without me. You can. I have faith in you. And I will be here tomorrow morning. Okay?